Section 1A, we're going to talk about collecting and classifying data. So the two major groups that we're going to look at is a population versus a sample. The population is all outcomes, responses, measurements. So it's everybody, every person, every measurement of, I don't know, the diameter of cookies. Do all the cookies. Whereas a sample is just a little subset or part or piece of a population. Okay, so like if the population is all Patriot High School students, then the students in this class would be a sample because you are a subset, a small piece of all of the students at Patriot High School. And when we collect data from a whole population, that's called a parameter. And if we collect data from a sample, that number is called a statistic. Okay, so if we were able to somehow get every single Patriot student to answer the question, what's your favorite cafeteria lunch? And let's say 68% said popcorn chicken. That would be a parameter. Whereas if we took a sample of 400 Patriot students, which is not everybody, and then 54% say popcorn chicken is their favorite, that 54% would be a statistic. And the nice part is they start with the same letter. So if it comes from a population, it's a parameter, P and P. And then if it comes from a sample, it's a statistic, S and S. All right, so you try this example. So they asked 515 US adults. That is not everybody. That's not all the adults that live in the United States. So the sample is the 515, which means the population would be all US adults. Okay. 31% said they believe in ghosts. That number came from a sample, so that is a statistic. The parameter in this case, we don't actually know what the number is, but it would be the percentage of all adults because we have the percentage of our sample. So our parameter would be the percentage of all adults. Okay, a lot of times in statistics, we are unable to ask an entire population because the group is too big. It would be impossible to get an answer from every single US adult. So we use samples or smaller groups to try and make an estimate about a big group. All right, the data that we collect, we can classify it into one of two groups, either categorical data or quantitative data. So categorical is like, think of it like categories. It could be colors, it could be anything really that's not a number. So we're describing taking data on coffee, the aroma, the appearance, the taste, those would all be categorical data. All right, quantitative data is numerical measures or counts. So how big is my coffee? 12-ounce latte, the temperature, the height of the cup. Now, we want to be very careful here. Not everything that's a number is automatically quantitative. All right, not all numbers are quantitative. Numbers that are used to count or measure things, those are quantitative. But we also use numbers sometimes to label or identify things, and those data would be categorical. All right, so we have an example here of the room numbers. Okay, think about your room numbers on your schedule. Would it tell me anything if I found the mean or average of your room numbers on your schedule compared to the person next to you? Right? No, we're just using numbers to identify the room. We could just as easily say this is room A, B, C, D. Okay, so that's kind of the question you can ask yourself is, does it make sense to average these numbers? If it does, they are quantitative. If it does not, then they're just labels, then it's categorical. Quantitative data can be further classified into two groups. We call it discrete or continuous. So discrete variables, they have fixed possible values that they could take. So if I toss a coin 5 times and I count the number it lands on tails, it could be 0, 1, 2, 3, 4, or 5. But those are the only options. It can't land on tails 2.47 times, right? So there's only those values that can't be anything in between them. Whereas continuous variables can take any interval. So if I'm measuring the height of you guys, someone could be 64 inches, they could be 64.1 inches, they could be 64.2, 64.3. It's a continuum, all right? It doesn't have specific numbers and can't be anything in between them, okay? All right, so we have learned how to classify data. Now let's talk about how to collect it. We're going to talk about four major methods of data collection, and the method that you choose is dependent on the situation that you are trying to collect data about. So, an observational study, we observe and measure characteristics without changing existing conditions. All right, so I'm not going to mess with anything. I'm not going to tell people certain things or tell them what to do. I'm just going to observe what's already happening. So an example with this would be if I went through like grocery store records to see how many people buy name brand versus generic brand cereal. Okay. In an experiment, however, I'm going to specifically and on purpose apply a treatment to part of a population and then see what happens. Think of this as like your elementary school science fair, all right? Where we are changing things for one group and then comparing the two groups. Okay, so if I have a group of diabetic adults, I tell half of them to take cinnamon and the other take nothing, and then I compare how it affects their blood sugar. That would be an experiment because I'm telling them to take cinnamon. Right? Simulation. This is where we use a mathematical or a physical model to reproduce the conditions of something. This is used when it's either super expensive or really dangerous to actually do things in real life. So we do simulations with crash dummies to study the effect of crashes on humans. We don't put human beings in a car and purposefully crash them to see what happens. We use dummies. We use computer models to try and estimate what would happen. All right, and then survey, that's when we want to know people's opinions about things. So we're going to ask them some questions. All right, you go somewhere and buy something, and later you get an email asking about your experience purchasing that thing. All right, so if we are doing a study of eating oatmeal on lowering blood pressure, I want to do an experiment there. I want to specifically tell people you eat oatmeal, you don't eat oatmeal. All right, if I want to know how fourth graders solve a puzzle, that would be an observational study. I'm just going to give them the puzzle and see what happens. A study of the effect on changing flight patterns on the number of airplane accidents. We should use simulation for that. I don't want to purposely put people in danger, and it's really expensive to build planes and then crash them. And then if I wanted to know US citizens' approval rating of Congress, the best way to get that data would be to do a survey. All right, and that's it for 1A.